want to start with, when I said enrollment, I meant like attendance actually. Let's do this thing, and maybe at the end we could discuss it with the time that you'll save from the silly quiz, because we have a silly quiz for today, and that shouldn't take more than like 30 seconds to do. So I need terms. Throw me a term, or throw me a term and define it related to probability. Quickly. I will walk out right now. Yeah.
Mutual exclusion.
So, okay, I'll write that. That's not the first one. That would have come to my mind. Mutual exclusion. Okay. Yeah.
Event.
That's the kind of stuff that I was thinking. Yeah, event. Okay. More. Yeah.
I guess outcome.
Outcome is the one I was thinking. Okay.
Sample space.
Are you reading it now?
No.
No. Okay.
More simple ones.
I am wondering, like, how did you get to that first? Like, that's actually really important because it determines if you can add or you have to worry about intersections.
Just the first one. It's math.
First. Okay. Anything else? Nothing? Okay, can you define them then? Yeah.
I guess with mutual exclusion, that would be like one only, if you have two events, if one of the events happens, then the other isn't able to happen.
Can we do that last, because it's going to rely on the other definitions?
Yeah.
It's almost like, yeah, but I'm going to go with you actually.
Okay.
Please remind me. Can anyone take like one of the earlier ones and tell me like what they think it means? Yeah.
Event would be like the things, like what happens to like which probability you're trying to calculate. Like, for example, if it's a deck of cards, probably you're picking up an ace. So
What was the experiment?
Deck of cards.
Deck of. You mean roll a die and it's like.
Yeah, like probably of getting a 6.
I think this term also came up, right? Experiments. You actually do something that's probabilistic and then you observe what happens. So I think this is actually a good place to start. You do something and it's going to lead to a result. You don't know what the result will be, but you have some expectations about the likelihoods. So that's our experiment. So you said sample space, right? Yeah.
Event.
Event, okay. I feel like event is also like the next highest here. I think it's easier to actually define these things. Are you all in agreement that experiment is the most foundational idea in here? Do you agree? Okay. So we're good with that one. It's the thing that you do that leads to a probabilistic result. I got that. Thank you. Next one. What's the next thing to do now? Yeah.
Say outcome.
The outcome is, yeah, how would you define it?
Just like the result of an experiment.
It's the thing that you see, right? So if I'm flipping a coin, is it heads or tails? If I roll a die, what number is it from 1 to 6? If I'm rolling a die, the event might be, are they the same or not, right? Like you conduct the experiment, you see something. So the outcome will be an element. And you'll see why I actually say that in a second. So what's the sample space? Someone other than the usual suspects. This is very disheartening, guys. Come on. What's the sample space? Ethan? If on your computers you have something other than discrete math, shut it down. You may still not know the answer, but I think that we can focus on this in a way that makes it memorable. So, what's sample space? Ethan? If you don't have it, just say it so we don't. Who can Google it the fastest? Go. Did anyone Google it? What is it?
Possible ordered outcomes.
Possible?
Yeah.
I just didn't hear the whole thing.
Oh, possible ordered outcomes.
Possible ordered outcomes. I don't know what ordered is. Like, I don't know why that word was given to you, but basically it's the set of all possible outcomes,
Okay.
right? So you roll the die. What's the sample space, actually? So if I roll a single die, what's my sample space?
1, 2, 3, 4, 5, 6.
There you go. That sounds like a set. It's a set of numbers from 1 through 6. So that's why I call this an outcome an element, because it's going to be one of the possible things that you anticipate seeing. Is everyone okay with this? So if I ask this again tomorrow, and if you don't know the answer to these things, what should I do to you? Sing a song? Like, you have no idea how bad are you really internalizing this? So, event. You had your hand up, I couldn't get to you before, but like, what's an event? I know it was a different question, but.
I mean, that's basically like a specific outcome that you're looking for.
A specific outcome, no. That's actually, I think that the type is different, because an outcome is an element, and you made it sound like the event was also an element. Do you want to go, or should I go with Gent? Yeah.
Something that produces an outcome.
What was that?
Something that produces an outcome. Would the event produce?
No. This is, so that's actually, you made it sound like it's the experiment. What you just said is more fitting for an experiment. Yeah, Ethan?
Is it a set of outcomes?
It's a set of outcomes. Okay, so I'm going to refer to this as S, right? Like samp S is my sample space or my universe. Like, it's basically everything that could happen. I'm going to refer to the outcome as E. In fact, I should actually call this like U for universe, like for all the events that I can see. So that's a set, and this is an element. Now, based on this, we say that E is an element of U, correct? An event is a subset of the universe. So that would mean that S is a subset of U. I'm using set notation to make these things very precise. Ethan, are you okay with this? I mean, you gave me the last one, so I suspect you are, but okay. Ethan, am I actually lying to you guys by putting this dash here, or is it possible that the sample space or the event could be the whole thing? Ethan first, and then maybe Jaden next, if you don't have an answer, Ethan.
I mean, I would assume so. It's,
That it should be here?
yeah.
That's good. And why?
Because if an event is a set of outcomes, it would be reasonable to say that it could be this set.
Yeah, can we come up with, like, it could be a dumb one, but like, what's the simplest example you could give where the event actually is going to be the entire universe, like, of outcomes? Well, how would you define an event so that no matter what you said, it must be one of the ones?
If you like roll the dice 6 times, you would get 1, 2, 3, 4, 5, 6.
With my luck, I would get like 6 ones. So that's actually not necessarily the universe.
Just
Actually, hold on. I promised you.
Well, if you like, if the question is, like, this one is kind of silly, like, what are the chances that you roll a die? Like, if the question is like, roll a die, I don't know.
That's good. But I can also say, like, yeah.
just building off of that example, like it could be rolling a die, and what's the probability of getting less than a 7?
That.
Like
You roll the die and you're looking for the probability of an event where the number you see is less than 7.
the sample space has the
Yeah. If you're going to roll that thing, you're going to get a number less than 7, so it's 100%. Yeah. So that would mean that that event is a subset of the universe, which is 1 through 6. Hey, guess what? That is the universe. So we have to permit them to be equal. Okay. Now, explain to us.
That's the saying that the probability of the union of event 1 and event 2 equals the probability of event 1 plus the probability of event 2 if the 2 events are disjoint, meaning that the intersection of event 1 and event 2 is the empty set.
Sounds good. Can you tell me like an example?
Like if you had a 6-sided die and you're saying what's the probability that you either get a 1 or 2 or 3 and a 4, like event 1 would be
Mhm.
1 and 2, event 2 would be 3 or 4, then the probability we just like add it together because there's no overlap.
Everyone hearing that? Everyone in agreement? Yeah, I think that I would have gone with something very similar. I probably would have defined my events. This is not going to be any better than yours. It's just to make it slightly easier to say. Event 1 is it's going to be an odd number. Event 2, it's going to be an even number. They are mutually exclusive. So the likelihood of one is going to be 50%, 3 out of 6. The other one is also 3 out of 6, but they cannot be satisfied simultaneously, which affords you cannot add them. And you get the probability of 100. Okay. Can someone give me another experiment where 2 different events defined on that experiment will not be mutually exclusive? So someone other than Connor, because he's the one who brought our focus to that. I'm actually, so can someone tell me what my question was in case you managed to understand me? And then let's actually answer that question. So what did I just ask? Yeah.
To define an experiment where the two events are mutually exclusive.
Mhm, yeah. So is everyone okay with it? So then everyone's thinking, okay, so do you have one or?
No.
Maybe in going towards like the event of rolling a dice, be something like instead of the outcome is a 1 or is a 2, it could be the outcome is 1 or greater, or the outcome is 2 or greater, something like that. So
I think that you're mathematically correct. I just want something that clicks more readily because of it comes from directly from life.
oh, okay.
Yeah, Jane?
I feel like, what are the chances that your first 2 die are odd, and then what are the chances that the second die is 1?
Good. You're, so it sounded like actually I think this is gonna work though. It looks like the first event required 2. What was, say it one more time?
So like the first time you roll, the first 2 dice are odd.
Mhm.
And then, or like the other event is that the second dice is 1, or like another odd. Or I guess, like if they should depend on each other, maybe the second dice would not be able to, the second dice would have to be even.
Yeah, so if it depends on it, it sounded like conditional probability, which is an important thing we have to do. The overlap of events is the very basis of conditional probability. I feel like we're getting closer to it, but is there something that is really just like makes it click? I don't have one right now. I can actually think about the Dunquist question that I wrote, like in the context of that I can think of one, but I don't have like something that's a little nugget that really reveals the idea. Nobody has an idea? How about this? One event is, I rolled a die and I'm gonna see an event that's less than 4. And the next one is greater than 3, greater than 2. Right? Like in that case, like 3 would satisfy both events. So it's not mutually exclusive. I think this actually gets the job done. I'm still not as happy about like it being like a natural 1 as possible, but like that conveys the idea, I think. Okay, so now nobody remembered, like I could actually turn over to Fisher and say, did you guys really cover this thing? But I'm not gonna say that because nobody remembered the thing that I taught on Monday, which was random variables. Thank you guys. What's a random variable? Robbie?
Random variable, function with sample space of real numbers.
What? Say that again?
Um,
Oh, I think, okay, say it again, I think that's good, yeah.
Random variable x is a function with a sample space as of an environment to real numbers.
Can you say that in English now, in a way that my roommate can understand?
It's a function of real numbers, whole numbers. No, just real numbers.
I'm getting the same sense that I get when I'm eating diet food. I'm not satisfied. Technically, that's correct. Is there anyone who could actually polish that a little bit? Yeah.
It's sort of a function that takes the outcome of an event as its input.
Yeah.
Or an outcome of an event.
And
whereas,
spits out?
a real number.
That's what he was saying, right? Like it's a function whose target is a real number, but then we have to make sure that we say there are some events that are not numbers, that are themselves not numbers. So then is there a mechanism so you could turn an outcome into a number so that, by the way, so that you could do an expected value, which is what we are covering today. That's the reason why random variables exist, so that we can actually say we could do an expected value. So you can also, actually we have to clarify this, but maybe not at this moment, but, well, no, at this moment, I actually insist, are we doing this? So I should actually have to do, so this is the set of real numbers, and so this is my universe, and these are the individual outcomes. Are we doing that with a random variable? Or are we doing it with all events over U going to real numbers? The reason I say that is because this one is saying that given the set of possible outcomes, I'm going to attach a function to every outcome and associate that with a real number so I can do some math on it. This one is saying that take this universe, figure out all possible subsets of it, and then associate each subset with a real number. So which one is it? Does the real number go from elements to a real number? Sorry, which one is it for random variables? Does it go from element to a real number or event to a real number? 10 seconds. Is over. Another 10 seconds. Yeah.
I think it did outcome.
It goes from outcomes to real numbers.
Real.
Okay. Yeah. That sounds actually a better way to do that too. That's like less problematic. Okay. What was his name? Hmm?
Who are you pointing at?
The fire. I can't have an attitude because I can't remember your name now. So what? So what did we just say?
I believe we were talking about random variables and how they're like an outcome that then points to real numbers.
Very good. Very good. You're still a mystery person to me right now, but like after I have my coffee, I'll remember.
Do you want my name?
That's gonna be so embarrassing. Yes.
Miles?
I want to say Amir because Amir actually sits over there, and for some reason I'm thinking of Amir. I know you're not Amir, but I couldn't think of Miles. But notice that those two names have the same length. Did you notice that?
Is it Amir?
Oh, Miles, you have one extra letter, yeah.
Yeah, I was gonna say, I have to.
Not a good day, not a good day. But you're, okay, so if you actually engage me more, I might actually perform better. So I'm gonna turn this around and say this is all your fault. So I think that we're okay with random variables. So here's one thing that I want to tell you. Like this is probably the best thing to remember about the point of the section for today, which is expected value. The expected value is a fancy way of saying anticipated average or future average. So in other words, you're going to do an experiment. It's going to produce an outcome, which is going to satisfy an event. And then you're trying to figure out what will be the anticipated average of that experiment if I keep doing it over and over again. So when you talk about an average, so you do an exam, what was the average score on it? Do you notice how it's in the past? Like it was an exam that was conducted. You could look at the numbers and calculate an average. Expected value is a prediction for that happening in the future. So let me actually just bring up the quiz question before we delve into the actual explanations here. So at every college, usually students, the highest number of, like in terms of first year, second year, third year, and fourth year, the highest number will be at first year because people come to whatever school, and then some of them transfer away because they don't find what they're looking for. It's called attrition. So IC has a bunch of students first year, fewer in the second year, yet even fewer in the third year, and hopefully not, but still fewer in the senior year. So it's kind of like a pyramid. Let's make this specific. Suppose that we have at IC first, second, third, and fourth years. We have 1,000 of them, 900 of them, 850, and 825. So 1,000 students come to IC, and then 900 of them choose to stay. And then 50 of them leave by the junior year. And then maybe a smaller amount, but still some people don't actually take the senior year there. So you have 825. Okay, so here's my question to you. And the question will be underspecified. Like you have to ask for additional information before you can answer this question. I go and stand in the middle of that academic quad, and people are passing by, students, and I keep asking like, what's your age, what's your age, what's your age? What will be the average that I encounter at the end of that silly experiment? Do you understand the problem as I said it? We have 4 classes, that many students, and I'm constantly like, let's say 100 times I ask the age of the student passing by, what will be the expected value of this experiment? As I said, there's missing piece here. Hey Miles, how are you?
I know that, like, logically, it's going, like, if they were all even, it would be like 2.5 or whatever, but because they're not, it's gonna be closer to 2.
Did you say they're like 2.5 years old?
No, like, I meant like grade-wise, cause age is a little complicated because you could have a freshman who is 22, you could have a senior who is younger, like, it's not, age is very subjective in terms of, because not every freshman starts at 18, 19, there are several who, they waited a few years, there